have the pleasure of introducing today's speaker, Bhargav Paripa. He has been an IBMer for over 27 years and currently is on the IBM Cloud Southeast technical team. He's dedicated hours learning about technology such as IBM Cloud, Red Hat, and Amazon, and has a number of IBM certifications focusing in cloud and the level 3 technical specialist. So Bhargav, why don't you take it away?
Thank you so much, Danielle and my team. Welcome to our webinar here. You see me here. I'm going to go here for a second and I'm going to start sharing my screen. So what I want to actually do right now for us is run a quick presentation at a high level so we understand why we want to learn this technology, specifically Red Hat OpenShift and IBM Cloud. I'm going to demonstrate a live demo on IBM Cloud, but a lot of things that I'm going to share with us. OpenShift works in any cloud in the exact same way, right? So that's number one. And then, so the plan here is, why do we care for Red Hat OpenShift on IBM Cloud or any other cloud service provider cloud, right? So the notable ones, Amazon, Google, Microsoft, or even Red Hat, right? So second is this technology, exactly what are the design aspects and use cases that OpenShift works or have in mind when OpenShift is being brought to life. What kind of requirements it's able to address and how exactly those use cases and requirements OpenShift is able to fulfill, right? So solutions or patterns or approaches to addressing those requirements and use cases. The third aspect I want to talk about is who are the professionals or personas or actors that this capability of OpenShift on any cloud is trying to address or meet or fulfill, right? Line of business. So business stakeholders, clearly developers, administrators, operational professionals, and security. So the stakeholders and the personas and how they might interact. Then we want to actually understand a subset of use cases, one specific one, which is in fashion today, and walk us through a live on IBM Cloud. Again, the concepts are applicable to Microsoft Cloud, wherever OpenShift runs, and pretty much OpenShift runs everywhere. The last but one point is again reassess if we can demonstrate it or we collectively have seen some of the claims that OpenShift makes in terms of its value, right? So that's a piece recap, and then there is a quiz. So that's the plan here. Now let's move on to use cases. So when I talk about or when we understand the capabilities of OpenShift, we're primarily looking 3 or 4 personas or actors. One of them is clearly developers. As a developer, what do I care for? And what are my challenges in my day in life of a developer, right? So developers' main goal is to iteratively add capabilities to their application and deploy as quickly as possible, right? So that's what my primary focus is. That's the way speed to value, speed to innovation, and my hard work gets to see the day of life, right? When you deploy to production environments. What are my challenges in that activity? I get distracted having to deal with variety of runtimes or having to deal with these non-functional things like security, transactionality, keeping the lights on. All these things these distractions will enable me not to be able to be agile or, deliver it to the speed that I want to. So one of the really standout capabilities of OpenShift is how speed to value, right? How my challenges as a developer are being addressed is on the right side solution. OpenShift gives you first on cloud. Cloud means a lot of things are managed by the service provider and you are not having to deal with it, meaning you can spin up your machines easily, you can tear down machines easily, you don't have to wait 45 days to get the box and configure it, all that, right? So quick, it's a fastest way to spin up and spin down, or fail fast or succeed fast. Second piece is cloud functions. um, Cloud functions are basically a serverless. All you do is my piece of valued business logic, I can drop into a cloud function which has the whole provisioning done for me, the box, the runtimes, the operating system, everything. I just code my function, and whatever I use for during that period, I get billed, right? So that's a speed to value. The second piece we are talking is automation and CI/CD, right? So with containerization. So that's a second value. Basically, you build a little bit, you test a little bit, you deploy a little bit, you do all over in a continuous integration, continuous deployment, automation pipeline manner, right? So that's the speed. The third piece is if I can offload or shift the responsibility of security and all the configuration, we call that declarative programming model, or security by policies, to someone else, that enables me to run fast. So I think that's what developers' concerns are value is. And one way we can help IBM together with you partners and customers is a garage. IBM Garage is a vehicle for us to realize this. Continuing on developer, second biggest thing that we get is typically companies are engaging in mergers and acquisitions. A company buys another company, oftentimes. And these companies exist their ITs in different clouds. So multi-cloud, hybrid cloud, some things on cloud, some things on data centers, on-prem, all these combinations are normal. When you have this kind of a distributed development happening in multiple disparate clouds or instances or locations, you'd have to deal with incompatibilities. Their runtimes are different. Their prerequisites on Microsoft Cloud may be different than IBM Cloud, may be different than Google. Um, Reconciling and aligning these multiple different environments with runtimes and prerequisites is time consuming, a nightmare, management nightmare, right? And oftentimes we get distracted as developers and we get overwhelmed. So what is needed, again, a potential is a standardized environment with container packaging, with Kubernetes orchestration, with enterprise grade Kubernetes, which is OpenShift instead of a community grade, with a automation, continuous CI/CD, and some kind of a centralized logging, centralized monitoring for observability and health checks and things like that. So that's what we're talking about. Second thing is security in cloud with a varieties of options in terms of configuring security, right? Uh, on wire, in storage, within the queues, uh, making sure, when you persist uh, wherever it is. So having all that security and continuously monitoring and making sure where we may have vulnerabilities, that's another piece that will be very helpful. Again, back to shifting the responsibility to a cloud service provider and having it as a managed service is a value. We are also talking about managing complex, databases or things like database as a service, either SQL, no SQL, or version object stores, or a combination of all those, even block and file storages. So I think that's a developer pain point and an approach to having a remediation. The final piece is this slide is talking about having to set up everything on our own and configuring everything on our own and then coming to our primary job. That is the problem. Again, capital investment versus operational, right? So end result, the pain point is, again, it slows us down. It causes in case you have something misconfigured or some outages happen. It's difficult. It's a single point failure. So, and even if you can do very well, it's a daily upkeep and the drift because of the patching, the velocity of changes happening, you end up with inconsistencies. So the likely outcomes of this way of managing would be exposure, risk, inconsistencies, and slowdown, right? So again, the theme here is if you have a cloud pack from OpenShift cloud packs are basically they are patterned capabilities, a collection of products putting together as a package that has best practices and patterns embedded into them and that is rigorously tested and certified that you can simply drop and that is also backed up by IBM for your support, right? If you can do this, that will give us speed, right? So that's what we are talking. And cloud schematics, it's basically automation. And by the way, when we talk about these remediations are path forward approaches with OpenShift, the main theme here is automation, leaning on managed service, and shifting the speed, the skills needed, and the distractions away from our primary goal to a service provider for all aspects so you have less risk, right? So that's the whole point here, separation of concerns. So that's what this slide is talking about, again through the perspective of a developer. If I now I'm going to go to the administrators and operators, what are my key challenges or what keeps me up in the night? Inconsistent environments, again we talked about because of distributed cloud development or hybrid cloud development. Inconsistencies, I have varieties of a sprawl of IT systems across these vendor uh, clouds or even on-prem or data centers. I am not sure I'm imposing the controls properly, consistently everywhere. I don't have proper visibility. Even if I can do on day zero, day one, day two, continuously keeping up, patching, applying vulnerabilities, upgrading to keep up with the business. It's all difficult and it is all very complex and it requires keeping up with latest skills, right? So what that means for enterprise uh, companies is more cost, um, distraction, and taking away focus from their main uh, you know core competency, right? So solution is OpenShift on IBM Cloud or any cloud. OpenShift runs everywhere pretty much. The second piece is cloud satellite. Satellite is basically if you can come to if you are an enterprise and you can come to IBM Cloud, wonderful, outstanding. But we understand sometimes you have other cloud vendors you have already standardized or invested in. In that case, some of our key capabilities and services that you love on IBM Cloud, they should come to this other cloud vendor, either Microsoft or Google or Amazon or even on-prem, right? So the cloud satellite technologies, if you cannot come to me, or if you have a solution that is multi-cloud, hybrid cloud across these cloud vendors, your answer to a consistent unified experience and visibility observability is actually through cloud satellite. And the other piece we are talking in the management tools is our key uh, getting control on this situation is really automation and managed service where possible. Let that management be done by someone else so we can actually focus on our core business. And by doing that, you are actually shifting the skills, the upkeep, and risk to someone else. And that someone else is on the hook to provide us service level agreements, right? So that's what we are talking. Again, security. Security is a big deal here, really. With everywhere we are talking about hacks and ransomware and hostage, right? So if you look at that, what this requires is we have to continuously keep up with correct security configurations on these disparate cloud providers or systems, right? Your controls have to be always on dot and perfect, cannot drift. If they drift, you have to be able to detect and be get notified and then do the remediation. That is actually, and also one of the key challenges for us is when you have these different cloud providers, all the big ones, each of their technologies and approaches are proprietary. There is no cloud standard, right? So what that means is you have inconsistencies, your skills are not adequate because your identity, access management, key management, your cloud object stores, all these things are different in each of these cloud vendors, and you're you're always behind, right? And compliance is another one for regulatory workloads. So IBM has capabilities, compliance center, security compliance center for compliant workloads, um, highest FIPS rated security within are on IBM capabilities in IBM Cloud. And then we have security at various levels. When you have storage, persistent storage on disk or in queues or in files, or on the wire when you're exchanging information, or in cache with Redis or Memcached. However, so basically you want again lean on someone actually managing it for you across these clouds, right? So that's the value of OpenShift. Now, what's the approach to being able to deliver the OpenShift capabilities? Clearly, containerization is the foundation. And the reason for containerization is it's a declarative and mutable way of doing things. And it's lightweight. The footprint is lightweight. It's not like virtual machines are natively deploying on hardware with a bare metal and operating system. Containerized uh, capabilities or containerized way of packing gives you portability and non-vendor lock-in. Containers run anywhere. And the third thing is it's efficient because it's speed to value, its automation is possible, and also a small footprint. And it's also more secure because you don't have the whole operating system on your box. You just have a very small footprint with a small exposure for hacking or for ransomware, right? So that's the foundation for actually OpenShift and Kubernetes and the whole capabilities. Now, you don't have to take my word. We have openly referenced white papers, videos, and the enterprise customers actually speaking on what their success stories resulted in and what the outcomes are, right? Typically, the outcomes are there is always a challenge or a pain point that's distracting our enterprise customer, in this case, UPS. There is a path forward with Red Hat OpenShift running on either IBM Cloud or multi-cloud or hybrid cloud. And then that results in outcomes for the stakeholders we talked about, developers, administrators, operators, and security professionals and line of business. And the savings are, and typical outcomes are either speed to value or operationalization or meeting the regulatory or workload requirements, service level agreements, or having the cost savings. In some cases, all the above, right? So I will give this for you to read at leisure. And I do want to summarize before I go into the demo, right? So what exactly in one nutshell OpenShift is 4.10? It's a trusted enterprise Kubernetes. What's the difference between a trusted enterprise Kubernetes versus a community Kubernetes? Uh, like, created Kubernetes from open source CNCF compliant. You have stability. You don't have a new release every 3 months. You also have an ability to depend on what works for you with a regression. So OpenShift is CNCF compliant. It is stable. It works when you move to a new version because it's regressed and it's verified by interoperable test suite. You can also maintain your posture when you deploy to production applications. either connected or disconnected way, and it works day 0, day 1, day 2. Day 0 is actually setting it up first time and one time, and day 1 and day 2 and day 3 continuing to keep up, maintain and derive value. It will do all that for you. It is a cloud-like experience. What is a cloud-like experience? It's basically elastically scalable for scale out or scale down. You self-service driven. You can actually pay for what you use and not pay when you don't use. Those are all things that you can actually experience with OpenShift, either in hybrid or a multi-cloud clusters. And you also have developer productivity, where developers can actually focus on their core capabilities or what they are trying to do and not worry about these distractors, right? This is another one slide that actually captures all the value props, and you can see all the certifications on the lower section of the slide. It talks about HIPAA workloads, uh, PCI workloads, ISO or NIST or SOC 2, SOC 3. So basically, it can handle the regulated workloads. Its automation is a key. Patching, upgrading, again, day 1, day 2, day 3, 24/7, site reliability engineering. So it's available in multiple zones, multiple regions. It's HA, non-single point failure. You don't have anywhere in the architecture vulnerabilities. So I'll leave it to you to read. Nutshell here. Final summary. If you are leaning on OpenShift managed, you're shifting the risk to someone else. What that means is you're saving the time. You are also leaning on experts and skilled professionals doing the configurations and upkeep rather than having to get distracted. Okay, that's this one. You are able to meet service level agreements because the reference architecture that OpenShift deploys to is highly available. It's 3 zones in one single zone, a single region, or it can be multi-region. It also has either in the workload business deployed applications or management control plane, no single point failures, so highly redundant. And you have service level agreements to that, right? It's scalable, it's cloud-like, meaning when the demand spikes, you have scale out deployments. When the demand shrinks, you have scale down, right? So there are more details here. A typical life of a enterprise production trends, how many patches you do, how many times you deploy your applications in a day, up to 20 times. It's difficult to do manually. Automation and managed service will help us, right? So what's the value of IBM running for you is explained here. Everything is air gapped, tight, isolated, multi-tenant. That means sharing of resources from a pool means less expensive, cost efficiencies, automation end to end, and it's high availability for either backup or recovery or DR or business continuity, right? Another simple way to explain simplified cluster management, design for your customization, multi-tenancy and isolation. Anywhere you have a gap that OpenShift today cannot fulfill you, it's extensible happily. It's pluggable and extensible, and you can roll out your own. It's a community driven, right? And it is native cloud, a native development way of doing things with agile microservices and things like that, and integrated tools actually end to end. So why would I care for OpenShift when I can go for Kubernetes? So OpenShift is actually 100% Kubernetes, and Kubernetes is kind of not 100% OpenShift, right? So that is what this slide is talking about. There are a lot of things that Kubernetes still will not address and would never address because that's not its mission. That's where OpenShift comes in and provides you capabilities, so you don't have to worry about that. Centralized logging, centralized monitoring, health checks, automation, right? So I'm going to now go to live demo. Here is the plan. Um, so I have 15-20 minutes. Okay. So what I want to show you is, first and foremost, I want to, let me just move this here, start here. So you can see I just logged in. So this is the way you log in on IBM Cloud, roughly similar if your cloud provider is somewhere else with OpenShift, exactly same. First and foremost, you'll make sure you're in the correct account, which is me here. Second thing, you can see right in this dashboard what resources I'm consuming. You can also see that right here. Resource list. I'm going to go here and show you. I told you automation is the key to get control. We have Terraform automation workspace that I deployed my cluster. I can show you here. The second piece I want to show you is storage is already provisioned through my automation for my cluster. What kind of services do I have? I have monitoring and metric service. I have a centralized logging with log DNA. This is sysdig. I have a storage NoSQL based persistent storage service, CloudEnt. I have certificate manager if I choose to use. You can also provision a lot more services. I have my cluster running on OpenShift and IBM Cloud, and my cluster has 2 worker nodes that I have provisioned here, and I can see them, right? Okay, so this is number 1. Number 2, what I want to show you is take us to the cluster. My focus here is to show you how easily we can do things, right? Almost like monkeys can do. I mean, this is where the value of shifting my hardship to someone else and me focusing on what I care for. So I can see 2 machines. I can see all the details. I can have integrated experience with my logging, with my monitoring, with my diagnostics right on this pane. I can also enable integration to my container or image security. A typical developer life to deployment is depicted. Just a second detour here is I have a team repo. I'm a developer. I check out from Git. By the way, I'm going to show you this right now as we go through. I will build. I will run my regression. I will do code analysis, static and dynamic. I'll put it in my Artifactory or some repository. I actually wire my pipeline and I containerize everything source to image. I put it in a container registry. I push and pull. I scan more to make sure there are no vulnerabilities in my images. And then I deploy to my multiple environments. Entire thing through pipeline. This is what actually OpenShift is going to do as I trigger that piece, right? So I have 2 worker nodes. I can see them where they are located. They can be in multiple data zones. Haven't deployed, but what version I'm running, what the public IP address is. I don't have to make them public. I can also show you where they are. Now, the second thing I want to show here is how do I create OpenShift? Let's look at that. Just so you know how easy it is. I'm not going to create, but I'm going to show you. First and foremost. So before I go, I am going to click on, I'm going to deploy for us this application and walk us through. This application is a classic microservices application. It has 3 or more tiers. You have a user interacting. You have a developer pushing their work into the production. You have administrators making sure things are set correctly. So I'm showing you a developer, admin, and an end user. Profiles are personas. I can also show you, I have my deployments running an OpenShift cluster on IBM Cloud within a region, within a cluster, and the solution has 2 pieces, front end and a back end. Front end is for the end user. Back end is where I'm storing the information, business knowledge. I develop my application for front end and back end in Node.js. I push it to Red Hat. It converts my source code into a Docker image or container image or whatever, you know, image format, UBI, puts it to a Kubernetes cluster. Through an operator marketplace automation, I wire my solution to a backend, and now I can see end to end everything. This is what we are actually, I'm going to demonstrate. Now, if I click on this, fear not, this exact thing is out there for you to do at leisure by yourself. You need nobody's permission. Step 1 through step 9, step 11. Okay, everything. So first step, we're looking, how do I deploy? How do I create a cluster? That's where I took a detour. How do I create a cluster? Go to clusters. How simple it is. As I said, monkeys can do. Okay, right here, I want a standard cluster. I want to define classic. Doesn't matter. The default resource group, wherever I want, single zone, multi-zone, just click, select the zone, Dallas 10, that's where I chose. Which kind of machine I want, how many machines I want, 4 core, 16 GB, ABCD, this is just what you use, you pay for. How many you want, I can decide. I want public or private or a combinational endpoints. You can select. I want encryption at every place, at disk, on storage, on wire, in cache, which version of OpenShift I want. This is, I'm showing you Kubernetes, but I can go to OpenShift and what integrations I want to wire, right? So I have shown you Kubernetes, but I meant to show you actually OpenShift. It's same exact. So go to clusters, create cluster, pick your choices. You see the right side, how much you might pay per hour, per month, per week, whatever payment model is. That's step 1 here. We have done the step 1. Now I'm going to take us to step 2. I'm not going to create because I just created. Go back to OpenShift, go to my cluster. Okay, I have the cluster already created. I'm going to go on my console. Okay, I'm an administrator. You can see I can be an administrator. I can be a developer. I already created my project. You can see here. If you look at the projects, I'm at home. If you look at the projects, I have gazillion projects, but this is the project that I already deployed. But what if I want to actually create a project? How do I do that, right? So I go to projects. I do a create. I'm not going to create, but I'm going to tell you how to create. You give the name, you click the button, ABCD, and you click the button, project gets created. That simple. Okay. So that's what I have done. So let me cancel. I created a health example project. It's all ready. I'm now going to be a developer. Okay. Before I go to a developer, I want to actually, let's see. I want to actually deploy. Go here. So if I want to deploy a project, which I already deployed, you can see here, how do? I do an add and import from a Git. And I'm actually going to, I won't show you, but I will. So if I go to Git here, I'm going to just show you how I would deploy. I'll put this one here. It detects for me. And all I do is I'm going to do some automation here. I don't have to give anything, just this one thing, the name for my project, which I already did. Okay, so this simple, right? So you deployed as a developer. Now we already deployed it. I can see I have my front end and I have my back end, right? So it's running. What can I now show you? On my front end, I can see what's running. I have a pod. I have already builds. I've done autoscaler. I have deployed. I can also go to my application and test it's live or not. For example, my application is running. I can access it. Okay, so the other thing I want to show you is all my containers that I'm actually they're running. I can inspect them, their logs as they are running. I can connect to them live into the container and I can do things, right? So that's that simple you're able to do. Now back on here. So let's go back to our script here. So we have deployed the application that simply pointing the git endpoint URL and it'll do, it'll read the code, it'll containerize the code, it'll deploy to the cluster that you have already created and it's running in a containerized pods. You can connect to the pods, you can actually perform some logging or you can view what's going on, right? So we're talking about logging. Now, whatever I'm showing you, I can also actually see that from command line. So I'm going to show you that now. For me to show us that, here is what I have to do. Command line access to your clusters is available right through the browser using the command shell, IBM command shell, and it's free for us. So I'm going to show you these three commands and I'll explain. And this way of connecting to your cluster is very safe and secure. So what I have done here is I'm going to paste. That's my Kubernetes cluster. I connected to my cluster here. I connected and now I can actually see what projects I have. I have one of my projects, the patient health. You can see somewhere up in the beginning, example health. Right, so whatever I'm showing you through the browser, I can do every piece of it through command line or API. That's one thing I wanted to explain. I'm also setting up some kind of logging for us, right? So I'm going to subject a workload here for us and prove it to you that live as the workload is running. So I'm able to connect to my application and pull some things. Now I'm actually going to do the same thing in a loop. So we can actually live see. Okay, so I'm running this now. So if I go back to my topology, I'm subjecting my pods to workload here. And I should see traffic coming in here. You can see actually some information that we have not seen before. Okay, so while it's actually moving called, you'll see it's going to start getting called, right? So this is actually a live runtime you are able to see. We can also see on projects and events. So if you go here, I can actually see as the traffic is spiking up, I can inspect. The other key things, I really one key thing I want to show you is this piece, auto scaling. So if I go to my workloads and I show you on the patient front end, I have 10 pods running right now. I can see my events. It scaled from 1 to 4 as I pushed the workload. You can see 4 minutes ago. And from 4 to 8 pods and 8 to 10 pods. You can see this happening as we speak, as we put the loop in, right? So this is called auto scaling. I can, and this has, and it will also auto scale down actually. So all full load, all 10 copies of pods are running right now, right? So this is one thing that you don't have to do. I mean, can you imagine buying a hardware and setting it up 45 days later and then shifting the workload and balancing? You don't have to do that, right? So that's the ease with which you can do. Now I'm going back actually to developer here. So let me show you a couple of other important things here. Now, as the workload is spiking and I'm seeing traffic, my service level agreements are being adjusted to, how can I actually see the live metrics and view into it, dashboards, right? So you have an ability to actually connect and see as the traffic is coming through Grafana dashboard directly, or you can also see through Red Hat's, I mean, OpenShift and IBM Cloud. For example, here, I can launch right this one. This is integrated right into the dashboard, all the capabilities you would normally see. This is monitoring, and let me also show you. So here, this is your monitoring and visibility and metrics, which you can see from IBM Cloud Console. Logging also I can see with Sysdig from IBM Cloud Console directly and so easily configured for you. You can also actually see from OpenShift console itself. So let me go back to OpenShift console. And if you are a developer, I can observe. So it's up to you how, it's up to us how we want to actually get the observability either through this main dashboard is showing you your infrastructure performance. How is my compute doing? How am I utilizing my compute? How is my memory? How is my storage? How is my bandwidth, right? You can also see metrics. You can see alerts. You can see events. I can see the same through Grafana. I can also see natively if I'm more comfortable and I have more skills in Prometheus, for example. I don't want to actually use these integrated other consoles. If I want to use Prometheus directly, I can absolutely do. So this is again, what's the value? It's a flexibility, and whatever tool you're comfortable with and whatever skills you have in your own tools, just have at it. It's not like we are enforcing on you. See, and you can also see if you're good with your own. I'm sorry, I have to go back here. I meant to click on endpoints. So your Prometheus is showing you all your endpoints that are running in your cluster for you if you're skilled in this. If you're skilled in Grafana, you're happy to do that. If you want to actually consume this from OpenShift console, web console, you can do that. If you want to consume this visibility and logging and observability from IBM Cloud Console, you can do that. Everything I'm showing you, if your cloud provider is Microsoft or a Google or Red Hat, works exactly like this. It's all integrated for you, right? So that's one thing I want to. So if you are a developer, you can see. If you are an administrator, of course, you also have an ability to observe and even more configure, right? So you can see dashboards right here. You have an ability to select your targets, you know, drill down into. I think, Daniela, can you tell me, I have a few more minutes? Or do you need to?
You have about 4 minutes. That's perfect.
4 minutes. Okay, so here is what I'm going to drill down. I'm going to show you a centralized logging, the beauty and the simplicity. So here I can see all the logs from all my setup, all my cluster members, right? I can see everything. I can actually filter on my cluster. I can filter on sources, for example, patient health. front end and back end. I can select, apply. I can see all applications, both front end and back end, apply. I can see just information. I don't want to see anything else. I only see everything information, right? I can search by application. I only see front end. I can search by since 1 hour ago or 1 day ago. I only see the time. So you have an ability to filter. Let's say I selected one line. What can I do? I can view that particular specific thing in context. I can continue to a completely new browser. I can copy to clipboard. I can share it with my friend. I can extract a subset of fields. I can do all that. Okay, so that's your ability to drill down. What other things can I do? I can actually create my custom dashboards where I can select, let's say, my front end, my back end. I can do some aggregation, and whatever aggregated view I'm looking, I can click on it and I can drill down on that view, on that metric, to specific details as to how that aggregation happened. Okay. What other things can I do here? Back to my, I can actually take my aggregation from a day or a time or filtered by whatever metric I have. I can actually drill down by further down within the histograms or within pie charts. I can do whatever I want here, right? So if I add another graph, I can, add another dimension, the pie chart. I can drill down on the data. So that's what we call is a new board. Another piece can I show you? This is the last field. I can create my own screens with my custom widgets, and that I can actually define what that widget shows on the right side with whatever formula I want. I want to see my application. Sorry, I went back. Front end, aggregation counts for last 2 weeks. Show me that. I can change it to environment, number changes. I can do everything. Similarly, I can see, further, this is a gauge, this is a count, this is a table, this is a time series. I can assemble my own Grafana like widgets, and I can also customize in case you have some rules within your enterprise where you have to protect or redact some information in logs. For example, you don't want IP addresses to be shown when you're sending it to IBM, for example. You can assemble what you sent your log actually has captures, and you can customize. So let me stop here and summarize last 2 pieces here. Let me take us to here. So summary, why should I care for OpenShift on IBM Cloud or wherever it runs? Really, it's a cloud native technology. It is modern. It is like cloud-like experience, auto scale, horizontal scalability, and cloud native. You have an ability to deploy your valuable assets consistently across these disparate systems. You have service level agreements. You are shifting the risk to someone else, and you have the highest certified security enabled for you. And this means it's speed to value, it's cost savings, and it's a separation of concerns. You can focus on your core innovation while you shift everything else, all the distractions and nonsense, to someone else as a managed service. Back to you, Daniela.
Great job, Bhargav. Thank you so much.
Thank you very much, Dan. And thank you very much, Bhargav, for that wonderful presentation. Thank you all for attending today's webinar, We appreciate you for showing up. And just for information, we'll have this record on our YouTube channel, and which we'll send out the link soon. So just go there, check it out. And in case you have friends or people who didn't show up for today, just direct them to the YouTube channel, and you will get all today's recordings out there, and the ones we had last 2 weeks and the future ones we're going to have.